Let's go to question 3. Let f of x equals 2 minus 3x to the fifth power over 2x to the third power. X is all real numbers, and x is not equal to 0. Point A is a turning point, and point B is an inflection point on the curve. The coordinates of B can be expressed in the form of this, where A, B are rational numbers. Find the value of A and the value of B. For f of x equals 2 minus 3x to the fifth power over 2x to the third power. Since B is an inflection point on the curve, which means f double prime of 2 to the 8th power equals 0. So we need to figure out the first derivative of f of x. Better way is separate 2 over 2x to the third power minus 3x to the fifth power over 2x to the third power. So we have reduce x to the negative third power minus 3 over 2x squared. Therefore, f prime of x equals x to the negative third power prime minus 3 over 2 times x squared prime equals negative 3 times x to the negative fourth power minus 3 over 2 times 2x. So we have negative 3 over x to the fourth power minus reduce 3x. Then f double prime of x equals negative 3x to the negative fourth power prime minus 3x prime equals positive 12x to the negative fifth power minus 3 equals 0. Because we are looking for the inflection point. So you get the 12 over x to the fifth power minus 3 equals 0. 12 over x to the fifth power equals 3. Cross multiply. 3x to the fifth power equals 12. X to the fifth power equals 4. Do the fifth root both sides. So x equals the fifth root of 4. Now we can set up 2 to the 8th power equals fifth root of 4. That equals 2 to the 2 over 5th power. So we have a equals 2 over 5. Therefore, for b, we will have 2 to the 2 over 5th power. b times 2 to the negative 3 times 2 over 5 will be negative 6 over 5. f of 2 to the 2 over 5th power, that equals 2 minus 3 times 2 to the 2 over 5th power, then 5th power, over 2 times 2 over 2 over fifth power, then third power. Power of a power we multiply. So we have 2 minus, reduce 2 squared will be 4, 3 times 4. That equals negative 10. Look at the denominator. We will have 2 times 2 to the 2 times 3 will be 6 over fifth power. This is 1. 1 plus 6 over fifth power will be 2 to the 11 over fifth power. So 2 to the 11 over fifth power. 2 to the 11 over fifth power equals each other to figure out B. B times 2 to the negative 6 over fifth power equals negative 10 over 2 to the 11 over fifth power. Since we have a denominator, multiply by 2 to the 11 over fifth power both sides. You will get B times 11 over 5 minus 6 over 5 will be 5 over 5. That is 2 to the first power equals negative 10. So we get B equals negative 5. Let's go to B. Sketch the graph for y equals f of x, clearly showing the position of points A and B. We will set up this equals 0. Negative 3 over x to the fourth power minus 3x equals 0. Since we have a denominator and x is not equal to 0, every single term will multiply by x to the fourth power. So we have negative 3 minus 3x to the fifth power equals 0. Then negative 3 equals 3x to the fifth power. X to the fifth power equals negative 1. Then x equals negative 1. Therefore, f of negative 1 equals 2 minus 3 negative 1 to the fifth power over 2 times negative 1 to the third power. 5 over negative 2 equals negative 5 over 2. So we get coordinate for A is negative 1, negative 5 over 2. We need to check this point is maximum or minimum. So f double prime of negative 1 equals 12 over negative 1 to the fifth power minus 3 equals negative 15 less than 0. So A is a maximum point. We need to show the position of the point A and B. A is easy to show. B part, fifth root of 4, negative 5 times 2 to the negative 6 over fifth power. We need to estimate the value. For 1 to the fifth power equals 1, which means the fifth root of 1 equals 1. 2 to the fifth power equals 32, which means the fifth root of 32 equals 2. Therefore, fifth root of 4 greater than 1, less than 2. Now let's check negative 5 times 2 to the negative 6 over fifth power. we can write down -5 over 2 to the 6 over 5th power. 6 over 5, we will change into mixed fraction, 2 to the 1 plus 1 over 5th power. So we have -5, 2 times the 5th root of 2. It will be greater than, because it's a negative number, -5 over 2. For rational function, you need to figure out intercepts and asymptote lines before you sketch the graph. So for the root, we will set up 2 minus 3x to the 5th power over 2x third power equals 0, which means 2 minus 3x to the 5th power equals 0. 2 equals 3x to the 5th power. X to the 5th power equals 2 over 3. So x equals 5th root of 2 over 3. It will be between 0 and 1. For vertical asymptote line, x equals 0. Therefore, no y-intercept. For the horizontal asymptote line, even there is no horizontal asymptote line, you need to figure this out because you can have a clue the end behavior of the graph. Y equals limit as x approaches the positive infinity of a leading term of this rational function will be -3x to the 5th power over 2x third power. Reduce. We will get limit as x approaches the positive infinity of -3x squared over 2. Substitute the positive infinity for x, you will get negative infinity. Y equals limit as x approaches negative infinity of -3x to the 2nd power over 2. Substitute the negative infinity for x, we will get negative infinity. So we can predict the graph. This is a vertical asymptote line. As x approaches the positive infinity, y approaches negative infinity. This part is x approaches negative infinity, y approaches negative infinity. First of all, we draw this vertical asymptote line. Don't forget label the origin, x, y. Also the scale, 1, 2, 3. Let's do 1, 2, 3. So we estimate the x-intercept is here, A. For B, x-coordinate is between 1 and 2. Y will be a little bit above -5 over 2. So we estimate over here. So we can predict a graph like this. This is a B. For the A, since this is a maximum, and this part will be that, A is a maximum value, so we can predict the graph like this.